Good morning, everybody. Today we are going to start a new chapter. This is not about your. No. Let me. Okay. We are going to start a new chapter. This is about namespaces and separate compilation. We know about the separate compilation a little from our C course. Namespaces, we have been talking about namespaces, but I didn't give you the details. Today we are going to look at them both. First, let's start from the separate compilation. Okay, this is what we are going to do. Separate compilation and the namespaces. Okay, so let's start from separate compilation. What do we mean by separate compilation? Why we are doing it? Okay. Suppose we have a large development team. I have, let's say, 5 developers, okay, and I am the lead developer, and I assigned 5 developers different tasks and asked the developer number 1 to implement a class named class A. This guy is implementing class B, and this guy is implementing class K, and etc. So each one work on their own classes. So they have their headers and they have their source files. And to test their classes, actually, they write their own drivers too. Okay. So this is kind of a typical picture of a development team. Everybody has their own task, and they are working on their own problems, their own class implementation. Since they know that they are only responsible from the public part of the class, okay, as far as the outside world is concerned, they can freely do whatever they want with their implementation, okay. The rest of the development, let's consider this developer 1. Rest of the development team can see only this header part of the code. The rest, of course, if they wanted, they can see it, but they don't have to see it. They see the public part of the class. The rest of them is outside the visibility of all the other developers, including the lead developer. So I can freely work on my project. This one can do the same thing. This one can do the same thing. So that's one of the benefits of object-oriented programming. Since I have isolated outside world from the internal workings of my class, my software system, I can freely do whatever I want, and this is a very nice way of working in parallel with many people. And the nice thing is that I have my main function. This guy has their main function, and everybody has their main functions, so that they can test their classes, okay, without asking anybody to test it. And as the lead developer, this is what I do. I write my main application code or the main driver. So all I do is I just include all the header files, and I run my test code. Okay, so this structure is very popular. It is used commonly with software development teams, and I mean, you don't have to do object-oriented programming to do this, but object-oriented programming definitely helps. Why? Because I know that the C++ or Java or whatever language you are using, the language helps you to isolate your interface from the implementation. Implementation is something different. Interface is something different. When you design your classes, you consider this first. I mean, what is my implementation? What is my interface? So maybe at the beginning of the project, these people, 10 people, come together and they design their class interfaces. They say that the class interfaces will be like this, this, and this, okay? Those are the interfaces. Once they agree on the class interfaces, they can continue and they can go on implementing stuff. Maybe this guy designed the class interfaces. He said that, okay, he or she said that these will be our classes, okay? We designed it this way. Now it is your task to implement these and fill them in with the implementation. Also test them too. Write your main functions and test them too. And after a while, I'll get all the code from you, including the .o files, compile.o files, and I will put them in such a application program and I will run them. If there is a problem with one of the classes, I know which class it is. I know the responsible developer. Okay. So, as I said before, you could have done the same thing with the C programming. I mean, you could say that, okay, these are the functions that you're going to implement, okay? Everybody has a function and etc. But as we said before, there are globals in C, there are global functions in C, and you wouldn't restrict anybody not to call that function, okay? If a function is a global function and if it is implemented in this file, okay, in this class A.cpp, everybody has access to it, right? You don't know who is calling that one. There is no restriction, okay? There are ways of restricting it, but the language itself doesn't help you in this sense. So object-oriented programming is very useful in this sense, in this case. Say that, okay, first, separate your interface from the implementation, make the interface public to everybody, expose everybody, okay, and be careful about your interface, because once you make that promise, this is my interface, you can't change it. Or if you change it, it will be a big trouble, big thing, because you have to ask everybody to say that, is it okay if I change my interface like this? Because people have been using that interface, right? So very careful design of the interface. After that, implementation is on your own. You can do whatever you want. Later, if you make a decision, later you will say that, first, I have implemented my class using the STL vectors. It works fine, but it is kind of slow. I'm going to change my implementation to C arrays, so to make it faster. Nobody will know that you have changed your implementation. Maybe they will realize that it is a little bit more efficient in terms of CPU usage and memory usage, but their code will compile and run as before. That's why we like separate compilation, okay? Keeping your interface from the implementation in two different places, and they are designed differently. We think about them differently, and we are very careful about our interfaces, because those are our promises. Those are our promises. Okay. So let's look at some of the examples of this philosophy of programming: class separation, class independence. And I have a few examples. The book says that, let's look at this example actually. Digital time. Okay. So this is a header file. This is a header file dtime.h here. Okay, dtime.h. We are going to use this class to keep time. So it will take the hour and the minute as the parameters to the class constructor, and here I have a no parameter constructor. These are two getters. Of course, they are constant, and this is advanced. You just add this many minutes to this value, and another one I am adding hours and minutes, and that's it, I guess. Yeah, and there are some static functions. For example, read hour. These are static because these actually private and static because this reader will not touch anything inside this class data members. Remember the dollars part and cents part functions of the money class or the bank account class? We didn't like them. We put them in the private section and made them static, and this is what's happening here, right? Still, I don't like these being part of the class because these are not actually part of the class. These are, I mean, reader doesn't, I mean, what was the definition of the encapsulation again? Put the data and the functions that work on that data in the same capsule, right? Data is hour and minute, okay? And these are the functions that work on that data. I put them in the same capsule, but this read hour, okay, it just reads an hour value from the keyboard and puts that value into this parameter hour. So it doesn't work, it doesn't do anything about this hour and minute, and it doesn't call any of them. In fact, it cannot call any of them because it's a static function, okay? But I still, I mean, instead of making this a global, I made this part of this class as a private function member. For now, it's kind of an acceptable solution, but we are going to find, at the end of this chapter with the namespaces, we are going to find a nice solution for this problem. Okay, so read minute does the same thing, okay? Reads the minute from the keyboard after read hour has read the hour. It's supposed to use that way. So again, it is just reading something and it is putting the result into this parameter. Okay, digit to int, it just converts this digit to an integer. We have our friend comparison operator. We have friend stream extraction and insertion operators. Remember, when you say friend, it doesn't matter where you mention them, okay? I don't like that they put these friends inside this private section. Although it doesn't matter where you put them, it would be better to put them in your public section so that your readers, I mean, I don't read rest of this private, okay? If I am the customer, I read only the public part. I read from line 10 to line 27. After that, I don't read because those are private. Well, for the friend function, it doesn't matter where you put them. So why don't you put them in this place? Because these will be global functions. Okay, just comparison of the time. And by the way, I don't know why they made this comparison function as a global function, because there is no conversion constructor available here, right? Since there is no conversion constructor, we won't be able to get that benefit from the converting an integer to a digital time, etc. But they did it that way, so we are going to keep it that way. So let's look at the implementation. Very simple class actually. Implementation is constructor. Okay, just check some if it is less than 24 minutes and the hour, etc. And then hour and minute. If hour is 24, then make it 0 and etc. Okay, and this is the second constructor. Make both of them 0. Getter is nice. Advance is add this many minutes to your time. So add minutes to minute and take the modulo of 60, and maybe we added more than an hour, so we are going to do this adjustment and hour becomes this way. The second advance will take both of them, hour and minute. So this is what you do. You add hours to hour, okay, and then you advance your minutes that way. Okay, so this will do both hour increment and the minute increment. Operator equal to, yeah, just check the hour parts and the minutes part, that's it. Stream insertion prints the thing to the standard output, okay, or whatever this O stream is. This is for the in stream. Okay, digit to int, very simple. Do you see this? What is this doing? What is this?
It's in order to convert a character to integer, you must subtract 48.
No, I'm not asking about this. No, I am not asking about this. I am asking about this. Int parentheses C. What is this?
Typecasting to get decimal value.
What?
Typecasting to get the decimal value of the type.
Well, it looks like this is kind of a integer has a constructor that takes a character, right? Conversion constructor, right?
Yes.
Conversion constructor. Integer has a constructor that takes a character, and I'm using the same conversion constructor here too. So two integers, if I subtract the integer value of 0, which is the ASCII code of 0, from the integer value of C, you will get a number. So for digit 0, I will get integer 0. For digit 1, I will get integer 1, etc. Okay, so read minute again. See, this one did not talk about the class members at all. It didn't say anything about. It needs all the information from the parameter list. That's it. So this is not. I mean, this doesn't follow the rules of encapsulation. This is not about the data. But instead of making it a global function, I made part of the class. I made it private so that I make sure that nobody calls this one. Kind of a controlled violation of the encapsulation rule. Read minute is just say that I have two characters, I am going to read them. It just reads them from the keyboard, okay, and both of them should be a digit, okay, and then my minute becomes digit int C1 times 10, so I am converting to a integer, and the minute becomes this one. So I am just modifying this one in this function. So again, I don't have access to data members. Even if I wanted to, I cannot because read minute is a what? Even if I wanted to, I cannot read. Okay, I cannot reach hour and minute in this function. Why? Because read minute is a static function. Static functions cannot access non-static data members and non-static functions, right? So again, the same thing is read hour. I'm just reading the hour, and if there is something wrong, then I will fix it, or I will terminate my program, etc. So that's it. Very simple program actually, and I guess this is the driver code. Okay, okay, let's look at this one. This is my header file. Inside this header file, I have my class declaration. That's it. Okay, so my customers are supposed to see this header file, and they are supposed to read. They are supposed to read from this part to this part. Okay, and they are not supposed to read the private part. That's what they say. You might say that, well, your private part is here. At least your private part is there. People can read the private sections of the class. Yeah, that's true. They can read it, but they are not supposed to read it. I mean, we are not trying to hide anything away from the customer. If they wanted to, yeah, they can read it. If they wanted to, they can get this code and they can look at it. But it wouldn't be for their benefit, right? It wouldn't be for their benefit. It is like in my car, I have only two pedals. One pedal accelerates the car, the other one slows it down. That's what I know. And there is a steering wheel. Okay? Three things that I know. But if I wanted to, I can pop the hood up, and I can cut some cables. I can reconnect some of the hoses to some other places. What am I doing? I don't know what I am doing, but I mean, the engine is mine. I can do whatever I want. And do you expect something useful out of that one? No. Of course, my engine is going to fail. My whole car is going to fail. I shouldn't do that, okay? I shouldn't do that. So that's the private part of the car. I should never pop up the hood and do that kind of stupid stuff. If your customer is stupid enough to get in there and do some, okay, this is hour and minute and I'm going to write my code accordingly and etc. Well, it's their problem, okay? You told them that public part is your place. Don't look at anywhere else. That's what we are saying here. So this is my header file, and this is my implementation file, and this is my driver code. In my driver code, I say that I am including this, dtime.h. And I have two clock objects, digital time object, clock and old clock. I get some values from the keyboard, and then and do the assignment. See, I didn't do the big three because, why didn't I have the big three? Because this is a simple enough class. There are no pointers. There is no deep copying involved, right? So shallow copy should be fine. So I didn't write the big three. Maybe I should have put a comment here saying that it is the default copy constructor, default assignment, and the destructor are okay. Okay, maybe I should have said that. They didn't do it. So with this one again, my implementation is here. Or I was talking about the okay. So I did the assignment here. I was talking about this file. Sorry. I did the assignment. Assignment works fine. Copy constructor works fine too. I did the assignment, and then I advanced my clock by 15 minutes. So both of them are not equal anymore because I advanced my time. And then I printed them out and another advance, and that's it. So very simple class, not much use for this, but it's a nice example to show you how to do the class separation of the interface from the implementation. This is just a customer code, okay? Customer code, and I can write this kind of code many times by including this dtime_h. Dtime_h is my it is my header file. It is my interface to the outside world. Okay, so I guess you did this before in your C classes, and we might have done this in our class too, but we never formally talked about this. So that's what we are doing today here. Okay, any questions up to now? Any questions? Any questions from the online people? Am I connected with the fast? No, I am connected. Let me switch to this one. So I will disconnect you a little bit. Okay, you had a question? Yeah.
Sir, the folder structure is important, like all header files in a file and all CPP files in a file. Is it important or?
Well, I mean, you should definitely try to avoid any implementation inside the header files. Okay? I mean, but sometimes we say that, okay, well, this is just a simple getter, just return the hour and return the minute.
I don't mean that. We are storing these files in a file, right?
Yeah, I have three files, the header file and the implementation file and the driver file, yeah.
Yeah. Is it important how we store?
What do you mean by how you store them?
Like in time.h
Yeah.
and time.cpp.
Yeah.
And date and age, date and cpp. We are storing in this a time folder, or we are storing the all header files in a folder and all cpp files in a folder.
Well, I mean, if this dtime.h or this dtime class is something that you are using in your current project, everybody is storing their classes in the same place, then keeping them in the same directory is okay because you are within the same development group. But if you are developing a commercial software and if you are going to sell your software to third-party customers, then you should definitely keep your compiled implementation files in a library or .o files. And of course, you should send your header files too. So this is how it should be done. And in fact, I think last week, today, like 7 days ago, right? Ilhan talked about this, right? He told you about how to write libraries in C, right? Did he do that?
Yes.
He did?
Briefly.
Yeah, so he told you how to write libraries. Library means this, okay? You compile all of your classes into the same binary file. Okay, you send that binary file to your customer along with the header files. Okay, the customer can see only the header files, and the implementation comes from the library. So implementation is linked to your executable during the linking process. So I never compile my vendor's C++ code. Okay, I compile my my own code with the help of the header files from the vendor. Well, we have been using, for example, this one. Okay, I've been using some libraries from these includes. Okay, and I have never seen their implementations. Okay, because these are linked during the linking process, and I don't have to see them. I never seen them. Your question is, where should I put my header files? I mean, in my current directory, I only see this dtime.h, okay, and dtime.cpp. So where are the header files for these? Okay, they are written at specific positions in the system, and let me see if I can. Okay, let me show you some compiler options then. Where are project, execute? Where are my compiler options? Do you guys see it? Tools. Yeah, compiler options are there. So in the compiler options, okay, these are the directories for the includes. Maybe it is a little bit small for you to see it, but it says that most of my includes are under this. Can I go there? Can I add new ones? Yeah, maybe I should just copy it and put it in here. Can I do that? The stupid thing is looking for it. Okay, yeah. Okay, so these are some of the includes that I have been using. This is in a standard place. And I tell the compiler that my standard headers are at these positions. And the other one is here. Let me get that one too. Let's try to find. Yeah. Okay, so these are some of the headers that I have. Do you see any, for example, this string here? No, these are the min GW. No, these are not standard headers. These are related to my emulation of the thing. GDI, no, these are not good. Let me find what else. Let me find, yeah, maybe these are the ones. Yeah, these are the C++ includes. Go there and paste it. Yeah, see, for example, the CC type is there. I am sure others are string. Yeah, string is here. So it's a header file, and I don't know why. Oh, okay, here it is. Let me open it with the notepad. Okay, so this is my string header file, and it has lots of includes. Basically, it's an include that includes lots of other includes. And we didn't look at the structure of the string yet. String is actually something a little bit different than what you can, than what we think it is. So basically that's it. So the answer to your question is, again, if you are using some standard header files, standard libraries, or some standard library from some of your vendors, their header files are put in these special directories, and you give the names of these directories using these kind of environment options. You say that my standard directories are here. You are going to look at the C++ includes at these directories, and my libraries are here. Okay, you are going to see my libraries at these positions, and let's look at some of the libraries actually. And in those libraries, you are going to see it's not going to be as much as many as. Okay, so .o files, as you see, some .o files, some .a files. These are the libraries, static libraries. For example, libstd. Where is libstd? Libs. Can I do that? I don't know why this one is doing this. Just stop it. I can look for it myself much faster. Okay. These are the, let me see if it is the S. Did you say it? These are M's. I mean, there is no single place to put these files. Yeah. These are SR. Yeah, maybe here. Yep, somewhere. Leave std. No, I think it is at some other place. stdio? No, I don't have it. Sorry, I couldn't find it. But it is somewhere here. Either in this directory or in the other directory. I don't know where they are. So you put these files in those special directories, and you tell the compiler that this is where they are. And when I try to compile this program, can I compile this? When you compile this program, see this compiler line. Okay, it didn't compile, but doesn't matter what it is. Compile log, yeah. So it says G++, okay, and this is my source code. -o is there. After the -o, I have my standard is C++11, and these are my include files. See, -i, this is my -i is my include files. There are many include files in there, right? Second include file or include directories. The third one. These are the ones that these are the ones that I tell the environment that these are my include files, and at the end I have the static library libgcc. Okay, these are the compiler options. Then I have the linker options. I am telling the linker that these are my directories. Then you should link with. That's how that happens. So I mean, I'm trying to answer your question for the last 10 minutes. If you have your own library, if you have your own header, you send your header to the customer, and you ask your customer to put that header in that special directory, one of them, and you put your library in that special directory too, and set the environment variables, and everything should work fine. You know, when you install something from somewhere else, how do you install it? You install with the apt get and apt install, right? Those kind of utility programs handle these kind of cases for you, these kind of details for you. They know where to put those headers and they know where to put those libraries. Okay. So for now, what we are going to do is, we are going to keep our header files and the implementation files in the same directory. That's what we are going to do. Good, let me move back. So we talk about this, class separation, class independence, your interface, keep your interface clean, very well documented. That's your storefront, okay? That's how your customers are going to see, okay? Keep it very clean, keep it very nicely documented. Doesn't matter if your customer is yourself or somebody else, because later when you come back and try to use your class, that documentation will be important. And you separate your class implementation, except the cases where it's simple getters. You may implement them in your header files, and you place them in 2 different files, okay? And if the implementation changes, okay, if the implementation changes, none of your customers has to compile their code, because their code depends only on your interface. They include the .h file. If you don't change the .h file, your customer's code don't have to be compiled. They only have to be linked, that's it, okay? And if the implementation changes, if I change the implementation in one of these files, either this one or that one or that one, only this developer has to compile his software system, and other than that, nobody will get affected, because all the rest, they only depend on their headers, nothing else. Okay, so this is a nice, actually, generalization of the encapsulation. Okay, so what did we say about the encapsulation? Data and the function that work on data. Okay, with the encapsulation principle, we separate how the class is used by the programmer from the details. Okay, with the complete separation, we achieve this interface in a file, implementation is in a different file, and we are just applying this encapsulation rules, and we are following the object-oriented programming principles. That makes our programs even nicer. Okay, so don't put your class declaration and the implementation in the same file. Put them in different files. That would be a better encapsulation than what we used to do. So some of the rules: all the member variables should be private. As a rule of thumb, if there are no exceptions, sometimes there will be exceptions. For example, sometimes we like to make our global constants as public data, constant data members, like the number pi, okay, or the number e, or I mean, these are constants, right, and they have to live somewhere. Maybe I can make number pi, maybe I should make a library named math, and inside this math, maybe there should be a number named pi, constant double, and nobody can change it, and I am using it this way. So other than these kind of exceptions, all member variables should be private, okay? And for all the private data members, if it is needed, you can write getters and setters. Sometimes you don't write setters, okay? Sometimes you don't write getters at all. So it depends. Remember yesterday's class, string class? Let me try to open that one. No, go to file, where is my string? Yeah, simple string H. This is my header file. So I have a getter for the length. Yeah. Should I write a setter for length? When they didn't write it, there is a getter for length. So we are just using the same principle. Make your data private. Yeah, we did that. So what did I say? For some of your data, you should write getters and setters. But which ones? I mean, I wrote a getter for length. How about the setter for length? I mean, we wrote setter for the dollar part, cent part, right? Maybe we wrote the setter for the time, hour part, and the minute part. How about writing a setter for length? Yeah.
I think a private member shouldn't ever get a setter.
No private member should get a setter.
Yeah.
How come we write the setter for the dollars part?
I mean, why don't you make it public? It's the same thing. No?
No, when you write a function, you have the control of how you modify that value. I mean, if you don't write a setter for the rational number numerator and denominator, how are you going to use it? You are saying that there should be no getters, setters at all?
No, if the
Well, I mean, I asked the same question when I first introduced setters and getters, and we talked about this. Yeah, I mean, if it is needed, you should write it. In this case, getter is needed because how else we are going to find the length of the string? Yeah, getters is needed. How about the setter? I mean, for the rational number, I should definitely write setters and getters for both numerator and denominator, right? For both of them. But I should be very careful about the denominator because if it is 0, then that's not a rational number anymore for the setter. Okay? That's the benefit of setters and getters. You make the decision that how you can modify those private data members. And I'm asking you here, I mean, should I write a setter for the length? And if I write it, what would be the code? Yeah.
It shouldn't be written because it depends on char data length.
Yeah. Length, you should never write a setter for length because length is automatically calculated from my string itself. Getter is fine, getter should be there. I ask my string how many characters are you keeping, but I cannot tell my string that you are going to keep 100 characters. So what are my characters then they would ask, okay? So writing a setter in this case is a very bad idea. And writing a setter for this data is kind of a bad idea too, but you might say that, well, we are doing it with this constructor anyway, right? This constructor is kind of a setter for the data, but it's kind of a controlled way because we are measuring the length and etc. So if you go back to this slide, it says that make all your member variables private, well, almost all of them, and you should write setters and getters for some of them, but not all of them. Sometimes you don't write any getter or setter for some of your data members. Sometimes you write them. Sometimes you write them very carefully. You will say that, okay, I am going to let you set this value, but you are allowed to set it only within this range, okay? Or you are going to set it within these rules, okay? So after doing this, after you're designing your data, setters and getters, okay, you add your public member functions or friend functions and your overloaded operators, okay, and that will be your interface. Okay, that will be your interface, and this interface it will be available to the customers. Okay, all the implementation and rest of the stuff will be private to you. The customers are not supposed to read your implementation. And again, I stress this out. We are not trying to hide these kind of implementation from our customers because of the security issues. We are hiding them. We are hiding this kind of implementation for the benefit of the customer actually. Customer can't do anything much useful by looking at the implementation itself or by using the implementation ideas. They are supposed to use the interface, and that's it. So that's again, these are just application of the encapsulation rules. And when you make this interface part different from the implementation part and put in different files, then your encapsulation is a better encapsulation there. Okay? Your interface file and the implementation file, that's what we did here. This is my, okay, see, this is my string, this is my interface file and implementation file I showed you yesterday, or this is my interface file for digital time, D time H, and this is D time CPP. Okay, good. Any questions so far? Any questions? Okay, let's take some break. Let's be here around 9:32, and let's open the windows. Did everybody sign this attendance sheet? Let's open the windows. Let's be back around 9:32.
Ben şeyi hatırlıyorum. Sınavda çıkabilir demiştim.
Okay, so interface file and implementation files are put in different places, and this is our convention. We usually, if I have a new class, I put the implementation in a file and I make the name of that class or file the same as the class, and the header file should be the same as, for example, for the string class there should be a string.cpp source file, and for the string class there should be a string.h header file. That's the kind of the convention. You don't have to do it this way, and in fact for your programs, I mean, if you have a header file, you don't have to call it a .h file. Compiler will take it, it will work. Or CPP doesn't have to be, the extension doesn't have to be CPP. Any file name should do fine. These are just conventions, okay? We give these kind of names for our convenience. It is okay to name your files file 1, file 2, file 3, file 4, file 5 without giving any extensions or any explicit header file names. It will work, but that will confuse you, that will confuse your customers a lot. That's why we say that if you have a new class, okay, you have a header file for it, myclass.h, and your implementation should be myclass.cpp. Okay? So typically implemented in CPP files, etc. We talked about these already. For your class files, usually, I mean, if you are using the Unix system make utilities, you write a make file, and I think you know how to write it from your C lectures. Or like this one, this is just a random integrated development environment IDE. Okay, this one will help me to handle these kind of stuff. Like, I mean, when I say compile, it knows which ones to compile. When I say make a new, for example, here's a project. With the project, how do I make a new project? Project. Okay, maybe, yeah. let's make a new project. With the new project, I can say, okay, what do you want? I want a Windows application or console application or library or DLL. So these two are for DLLs. DLL is a special kind of a library. And when I say console project, I got this. Okay, inside this project, I'm going to put it in, and I'm going to delete this later, so I'm going to put this in there. Okay, I have my project, and inside this project, I have only this one. So with this project, I can add files, add a file to the project. Okay, so where would I add those files? I think, let me add this CPP file. So I added one file to this project, I guess. And when I compile this project, it knows which files to compile, it knows which files are the header files, and etc. And I can change all of my compiler options, environment options. See, these are my environment options. Directories, see, these are my default directory or template directories, language paths, external programs, and etc. So these kind of things are either adjusted by yourself, or it will be, how come I don't, okay, I can close it this way, right? Close. Or it will be adjusted by yourself. Okay, usually we ask people to use IDE, either Eclipse or Emacs or Dev++ or whatever, Visual Studio, whatever you are comfortable with. Usually when people start using IDEs, they don't use it just for C++, they use it for C, they use it for Java, they use it for some other programming language too. So it is up to you what to use it, but it is important to know what is going on behind the IDE environment. I mean, some people, I have seen people, they think that this interface is this graphical interface is the interface of C++ programming language. Okay, they say that, okay, hit the execute file, hit the execute menu of the C++. I mean, this IDE has nothing to do with C++. This is just an IDE, just a graphical interface. Compiler and linker are your main things for the language. So don't let these two different things confuse you. IDEs are very different from the language itself. Okay, so we talked about this. Multiple copies of header files. There is a problem like this. Let's say I have one nice header file, let's say time.h. Inside time.h, I have this class definition, class time, whatever, okay. So this is my header file. I have a customer, okay, customer writes code, says that, okay, I'm include time.h and write some code, okay. For some reason, if I include the same time.h, the second time, since I am defining a class here, so that class time will be defined 2 times. It's like saying integer a and then integer a again. What does the compiler say? Compiler says you have defined this integer 2 times, and the same thing will happen here too. The compiler will tell me that class time is defined 2 times, and that's a bad thing. So I shouldn't do this. So ask your customers not to do that. But this is a customer. I mean, I don't know what the customers are going to do. If they do such a thing, it will be a problem for them. Maybe I should prevent it. And sometimes actually it is not easy to prevent this problem. Why? because let's say I have another header, let's say day.h. Inside the day.h, I don't know the classes, whatever, but this day.h includes time.h. Okay, so that's how it is defined. So day.h is using time somewhere in the class definition. As a customer, if I wanted to use both of them, okay, day.h and time.h, this is what I am doing. I included time.h, so I am free to use the time class now. I am including day.h, I am free to use the day class now too. But day.h includes the time.h, so I end up including time.h 2 times. So the same problem happens again. So I mean, sometimes there is no way for your customer to avoid this problem. It's going to happen. So what do? We get help from the preprocessor. We ask the preprocessor, did you compile time.h before? If it says yes, then I say, okay, now I'm not going to compile it anymore because I have compiled it. So how do we do that? We do that using preprocessor directives. Let me find them somewhere. Yeah, this is how we do stuff. Remember our time.h? Let me close this one. And let me close this one, and this one. Don't save it. So our time.h became like this. I am asking the preprocessor, is there a flag named dtime_h defined before? If it is not defined, then I am going to define it, and I will do this digital time h, and at the end this is my endf. If this one is defined before me, then I will immediately skip to line 53 because I'm not going to this. I'm not going into this this class definition anymore. Okay, let me open 11.5. Where is my 11.5? 11.5 is here. No, 11.5 is bad. Close this one, or maybe I should just open the time.h and then times cpp and time demo cpp. Get rid of this one. Okay, so time.h this, it says that do discarding. Okay, and my time cpp, I don't have anything about this defined thing. Okay, so it is okay for me. Is my project open? Can I close the project? Close project. Okay, good. No. Yeah. Now I can compile this thing. Time demo cpp. I hope it compiles. If I didn't compile it, I think it compiled. Didn't it compile? No. What does it say? Undefined reference to digital time. So I did not include the time h. I think I messed up when I opened that thing. Okay, let me compile this one first. It says, oh, that's what happens because, yeah, so this one, undefined reference to WinMain. I open the console application as a project. This guy thinks that I am still in a project. So even though I close the project, still thinks that I am trying to compile a console application. That's why it says win main. I don't see that in win main. So anyway, if I compile this one, it will just include this one, and it doesn't matter if I do this many times. Since the first time it included, okay, it will define this dtime h, dtime underscore h. The second time it is included, okay, it will not redefine it because it is already defined, and it will skip that one. So it is okay to include dtime h many times. Okay, so this is called preprocessor guarding, and this is kind of a standard way of doing things. Whatever header file you look at, you will always see this kind of a header like you have seen in the string header. Okay. So preprocessors, I mean, in C++ up to now, we did not use any preprocessor stuff. We said that stay away from the defines, right? Instead of defines, we have the consts. What else? Other than that, all the preprocessor stuff that we have used are the includes. Now this is the second time we are using the preprocessor. We are asking the preprocessor, just remember that I have compiled dtime h before, okay? So that will tell me the second time not to compile it at the same time. Of course, okay, you need to be able to compile this. Can I like to just, okay, no, I like to start it again so that I can compile it. Okay, this one, open it, and the third one is the time CPP. Yeah, I hope this compiles now. No, it is still saying the same thing. Where is my function main? My function time demo, it still says undefined reference to win main, because I opened that stupid project. Yeah, collect to. I was going to show you this. Okay, okay, since I have two CPP files, you need to call the compiler 2 times. One is for time demo CPP, the other one is time CPP. Okay, but both of them are including this time.h. That doesn't mean that my time.h will be compiled once, because when I call the compiler for time demo CPP and time CPP, okay, when I compile them separately, I am running 2 compilation units. Okay, I am using the compiler 2 times, but each time I am using the compiler, I am including the time.h. Okay, so I am trying to get back to this the concept of compilation unit. Okay, compilation unit is okay, every time you make a compiler call, compile this for me, you are creating a new compilation unit. And in this case, I have 2 compilation units for this project. One is time demo CPP, the other one is dtime CPP, and both of them include dtime.h. See, time demo CPP and dtime CPP, they both of them include dtime.h. That means that dtime h could be in both compilation units. Okay, and every time I make a new compilation unit, okay, the preprocessor runs again, and it lets the dtime.h to be compiled again. So in that case, for two different compilation units, okay, this guard mechanism doesn't kick in, okay, because these defines are only valid for a single compilation unit, okay. So this problem of including the digital time two times happens only within a single compilation unit. We will come to compilation units in a few more minutes when we discuss about the namespaces. So you did this already in your C lectures, guarding against the double inclusion, multiple inclusions, and this is a kind of a standard way of writing header files. From now on, you are going to do this, separating your interface from the implementation, and from now on, you will always write these if not def something and define it and do it that way. That's the kind of the standard way of doing things. Okay, any questions? Any questions about double includes, multiple includes? You already knew this, right? You knew this in your C programs? Say yes or no. No? How many people say no? 0. How many people say yes? Okay, why don't you say anything? So you already know that, okay? So we are going to use the same idea. Okay, if not def, preprocessor has many other things like the macros and the pragma statements and that kind of stuff. We will not talk about them. Okay, so if there are no questions, let's talk about these namespaces, okay? We have been using namespaces, and the first time we use them include use namespace, std, etc. I told you that we are going to discuss them later in the semester. Now that's the time. Let's look at their definition. The name definition is this, okay? Collection of name definitions, class definitions, variable definitions. You say that I have a namespace. Its name is std, and I'm going to put these classes into this namespace. String class, okay, vector class, linked list class, this class and this class. So you make a new namespace name, and you put your class definitions, variable declarations, function declarations in that namespace. When the time comes to use those classes or functions, you say that I am going to use this function inside this namespace. Okay. So namespaces are, again, definition is very simple, a collection of name definitions, and that's it. There is one big standard namespace in C++. It's called the std namespace, and all the standard classes, functions, and etc. They are all defined in that namespace, std namespace. That's why, in order to be able to use the string class, you need to say that I am going to use the standard namespace at the beginning of your file. Otherwise, the compiler won't know what you are using. Okay, what you are using. Everything has to be in part of some kind of a namespace in C++. You might say, so up to now, you have never said that I am going to add this class to the namespace. Yeah, we did not. Let's look at this program, actually. I mean, it says that I am going to use the standard namespace, but this one doesn't say that I am going to put this digital time inside the standard namespace. Okay, yeah, that's true. So where does this digital time go? Is it in the standard namespace? No, it is definitely not, because standard namespace is standard. You don't change it. You should not change the standard namespace. You should have your own namespace, but where is my namespace here? When we will talk about it. But Whatever you do in C++, all the class definitions, function declarations, global function, they go to some kind of a namespace, whether you defined it or not. Okay. My program uses many classes, functions, and all of them will be go to namespaces. So far we did this using namespace std, and inside the std we have many definitions like the strings, cout and seed objects. Remember those? If you like to if you like to have a variable named cout, integer variable, and its initial value is 7, you can do this. Don't include this statement using namespace std. Okay? If you don't include this using namespace std, you are telling the compiler that I am not going to use a standard namespace. So that means what? The name cout is available for you. I am going to make a declaration of cout. It's an integer, and its value is 7. And I will have a class named string, and I will do that. It is okay. You can do that if you like, as long as you don't say using namespace std. Okay? So namespaces are kind of ways of arranging your classes, your functions, in a nice and tidy way. And you could do this kind of stuff if you like, if you don't want to use the standard namespace. Of course, you shouldn't do this because everybody knows about the cout object. Everybody knows about the string object and etc. String classes, sorry, etc. That would be kind of confusing, but it is possible. It is possible. So it is possible to make cout, cin integers or new meaning to a vector class. You could do that. Okay. I'm giving these examples just for the sake of telling you what the namespaces are. So this is my namespace std. Okay. We use them all the time. We are telling the compiler that from now on, after line 11, okay, if I talk about cin, cout, string, etc., I am talking about the cout object that is defined inside this namespace std. Okay, that's what I'm saying. After this point, that's the meaning of it. But this digital time does not belong to namespace std. I didn't say that. I just said that. Okay, this line doesn't tell the compiler that I am extending the definition of std. Say that I am going to use this namespace std in this program. Okay, let's talk about this global namespace. What did we say before? In C++, all the definitions go to some kind of a namespace. If you define your namespace, if you tell that this is my namespace and I am going to put these class definitions into this namespace, that's fine. But if you don't do that, everything that you declare will go to this global namespace. Global namespace doesn't have a name. You don't say namespace global, okay? If you don't specify anything, then this class definition goes to global namespace, okay? So digital time or any global functions, any classes that we have written so far, we put them in global namespace. So what do you do to use the global namespace? Are you going to say using namespace global? No. To be able to use the global namespace, you don't write anything like line 11. You just use those. So everything is, unless put in some other place. If you don't specify where you are putting your classes, okay, everything goes to the global namespace, and global namespace is always available. Okay, is always available. That's what the slide says. Okay, all code goes in some namespace. If you don't specify where your code goes, then global space namespace is used by default. And global namespace is always available, and it is automatic using directive. You don't say using namespace global. You cannot say that, but the compiler assumes that. Okay, so you did not realize it. We didn't tell you that, but we have been using namespaces. We have been adding our stuff to the namespaces from the beginning. Since we did not specify the name of the namespace, it will be the global namespace. Okay. Okay, one thing here, if you like to, use the namespace that is defined into, if you like to use inside this program, after saying that using namespace std, I know that cout, cin is defined in there. If you wanted to say things like int cout, this will be an error now. This will be an error. Why? Because you are trying to use this as an integer, but it is defined inside the std namespace, so that's going to be a problem. If you don't use this one, no problems. If you don't use no problems with this one, but if you use it, of course it's a problem. But if you don't use that one, then that means that cout and cin will not work properly, and you will not use many things that we use from the namespace std. This is what that slide says. Inside multiple names, if you have two things defined both in global and the std, you either use global one or the std one, if you like to. Maybe there is a solution like that. Let me show you some solution. Go to d times cpp. See this cout here? I am not going to use this one, but every time I use a cout, I will say I am going to use the cout from this namespace std. This is fine. This will work. And if you want to make a global variable name cout and its initial value is 3, this will work, because I didn't tell the compiler that I am using the namespace std, but every time I am using something from the std namespace, I give this full name std cout. What else do we have here? I have cin and cout. Other than that, I think I did not use any. Yeah, again, std, these are the std stuff. This digit to int, I think it is this. I am not sure about that, but yeah, like that. So these are part of the std namespace, and I am using them with their full names. Digit to int is a function. It is defined inside this namespace std, because I didn't use the directive using namespace at the beginning, just to be able to write this. So question: what namespace is cout in? What is the namespace of cout here? It's a global namespace, right? It's the global namespace. So whenever I use cout, and that will be an interesting thing here. Let me show you this one. So I could say this.
Yes.
So this will print 3 on the screen, and the first cout here is part of the standard namespace. This one is part of the global namespace. Of course, you shouldn't do anything like that. This is stupid. But as I said many times before, we do stupid stuff to learn stuff. So let me get these out so that I don't forget. Good. Any questions? Yeah.
Sure, I understand the namespace, but where is it located in object-oriented principles? Yeah, why people need to namespace?
Yeah. So I mean, this is object-oriented programming course, and we are talking about the namespace. They are nice, but in terms of object-oriented programming principles, which one is it? I mean, this is part of the encapsulation again. Okay? Why? I mean, why did they make the decision of putting the separate compilation and the namespace into the same chapter? Because they are extensions of the encapsulation idea. Why? Because encapsulation means what? Your data and the functions that work on data are part of the same capsule. Okay? How about this? Your related classes and the definitions are part of the same structure. Okay? That's kind of an extension of the idea of the encapsulation. Encapsulation tries to keep things that are related to each other in the same place, so that I would say that, okay, my developer number one, your namespace is this, and my developer number two, your namespace is this. Developer number three, your namespace is this. They can do whatever they want inside their namespaces. And in fact, they can use the same class names too, right? Because it is up to them whatever the decision they make. As long as whatever they expose to the outside world from their namespace is valid with me, then I should be okay. So this is kind of an extension of the encapsulation idea. Okay, keeping the things in check. And remember, I kept saying I really don't like these being part of this class private part. Okay, I will take this out from this class definition. I am going to put them in a special namespace, make them kind of global, but they won't be global because they will be only valid within this namespace. Nobody will be able to use it. Okay, so that's kind of a solution to this problem of encapsulation. Make the encapsulation more general, make it more useful, and obey the object-oriented rules. And namespaces are valid with the Java programming language too. So they are not anything outside the object-oriented programming idea. Any other questions? So that was a good question. Sometimes I feel that you are listening. Yeah. Okay, so you could use namespaces like this. Okay, a block like that, a block definition. Inside this block, I am using this namespace and my function. And inside this block, I am using this namespace. So this is my function, either belongs to namespace 1 or global namespace. This my function either belongs to global namespace or namespace 2. Okay, so the using directive has block scope. You can switch between the namespaces, like using this block curly brackets, and do whatever you want. So when we say using namespace here, it doesn't have to be at the global scope. You can put brackets and say that this part of the file will be using this namespace, and this part will not be using it. It will use some other namespace. So namespace definition, this directive is, okay, block scope. This namespace directive is block scope. Okay, finally, let's make a new namespace. Making a namespace is very easy. You just say that it's like the class definition. Class something, namespace something. But at the end, I don't put a semicolon. Okay. Inside these curly brackets, whatever you put, they will go to this namespace. Okay, whatever you put in there, it will go to this namespace. It will place all the names defined in some code into namespace. Okay, and later, if you like to use namespace, then you say using namespace this one. I am kind of running out of time, but let me show you one example. This dtime stuff, we are going to make a namespace version of it. Let me close all of them. No, I am not saving you. Open it. Open it here. So open it. How do I go to this one? Yeah, I think it was in here, and source code chapter 11, this one. Yes, I can do this. Yeah, open all of them. 1, 2, 3. Get rid of this one. Close. Yeah. So my header file. Header file says that, as you see, I am defining a namespace. Its name is D times Savage. Remember, Savage is the last name of the author of the book. So usually you try to make your namespace a very unique name. Either you put your last name or the company name or the university name. So this is the namespace for D times Savage. Inside this namespace, so it starts at line 10 and it ends at line 55. So I put this class definition in D times Savage. Okay, I put it in there, no problems. And then in my D times CPP, I say that I am going to include this D time H, but see, I didn't say using namespace std. Instead, I am saying using std, iStream, outstream, okay? So I am specifying the names one by one, so that I don't use the whole namespace std. Just a one way of doing things. And then at line 11, I continue adding more stuff to my D times Savage namespace. So I have created a new namespace. I added this class declaration in it, and then I continue adding more stuff in it. Okay, I continue adding more stuff. All these implementations will go to this namespace, D times Savage. So when it comes to writing the driver program or the application program, this is what I do. Okay, I am going to use namespace std. Also, I am going to use D times Savage. Okay, both of them. So when I say digital time, compiler is smart enough to scan the std namespace to see if there are any definitions from there. Digital time, it is not there. It looks at this namespace. If it is there, it uses. If it is not there, then it checks the global namespace. If it cannot find any of them in there, okay, then it will say that I can't find the time, digital time anywhere. Okay, so I have nicely created one namespace and I used it. And this function main, where does the function main belong to? Does it belong to D times Savage or std or what? What is the namespace of main? Yeah, it is global namespace. It has to be global namespace. Otherwise, your compiler cannot produce a executable code. Okay? So exactly the same thing I wrote, and it will work. Okay? So think about namespace as a generalization of the encapsulation principle, generalization of the class structure. Okay? Within the class, you put related data and the functions on it, and within the namespace, you put the related classes together. Okay, related structure together, and that will make you even more modular, more independent from the other developers, more localized. And by the way, I mean, if you define a global function in a, why don't we like the global functions? We don't know who is going to call them, right? And why don't we like the global variables? We don't know who's going to modify them. If you make your global functions and global variables part of the namespaces, okay, we are kind of restricting our customers, saying that, I mean, if you're going to use these, then you have to be part of this namespace. That's kind of a solution to the global function and global variable problem that we are having, right? So, and there is another nice namespace solution to this problem again. There is an unnamed namespace, okay, special namespace. Global namespace is a special one, and there is an unnamed namespace. That will be a much better solution to our global functions. And today, I don't have time now because I am way over my time. I will stop here, and on Monday, we will finish up this chapter by discussing the unnamed namespaces. And I will start talking about the templates. Templates are the types of classes like the vectors. Remember, with the vectors you say vector of integers and the strings and etc. with the angled brackets. We are going to do that on Monday. Okay, see you on Monday. Please study, please read the book. Come back with your questions.